Section 7.6, solving multi-step inequalities. So again, just like our sections on solving equations went, where we solved adding and subtracting, we solved multiplication, division, and then we introduced the multi-step. It's the same for the inequalities. So that's our learning target, to solve inequalities that involve more than one operation. And we solve them just like equations, but we have that special rule from 7.5 where the sign stays the same unless we multiply or divide by a negative number when solving. Then we flip the sign. So let's look at some examples. Here's just two-step inequality. So if we start, right, just like we were going to do with an equal sign, right, here's my variable term, so I want to get rid of this number. So I'm going to do the opposite, which would be subtract 15 from both sides. So that would cancel. On this side, I'm left with 6 times x. 9 minus 15 would be negative 6. Here, divide both sides by 6, and we are left with x over here, and this would be negative 1. Now, we have to decide, do we flip the sign or not? Okay, and a lot of mistakes are made because we see this negative 1 as my solution, and we say we want to flip the sign. However, we divided by a positive 6, so my sign has to stay the same. All right, now if I look here in number 2, right, it's negative 3 times x. So I should be thinking to myself, I'm probably going to have to flip the sign at some point because I'm going to have to divide by a negative to solve for x. So we'll start by subtracting the 2 to both sides. So we would have negative 3 times x, right? That would cancel to be 0. Negative 13, negative 2 gives me negative 15. Now to divide both sides by negative 3, we get x over here, we get positive 5, right? Negative and negative in division equals a positive value. Now I divided by a negative when I solved, so this sign has to flip and go the other way. So my solution is x is less than 5, right? So if somebody says, well, what is the solution to that? Well, give me a number that's less than 5, right? 4 would be a solution, make this statement true. 3 would be a solution, it would make the statement true. On a number line, anything to the left of 5, right? So that would include 4, 3, 2, right, all the way over into the negatives. Okay, we're not going to graph these, we're just solving today, but that's what that inequality means. Now looking at number 3, my variable's over here, right? And I could flip this right off the bat, but I'm going to solve for it and leave it on the right side, and then I can flip it at the end if needed. So I'm going to start by subtracting 40. So over here, 42 minus 40 would be 2. Here we have 2x, right? And that cancels, right? 40 and negative 40 is 0. So now I'm going to divide. Right, 2 divided by 2 is just 1, so that cancels. I'm left with x here. 2 over 2 would just be 1. I divided by a positive, okay, so my sign's going to stay the same. All right, and it's fine to leave your answer like this. Most answer keys will have the variable first. A lot of times on multiple choice, just depends on what the choices are given. But you should be able to flip this around and know that it would be x, right? See how it's opening to the x? I have to open it to the x here. These are saying the same thing. X is greater than or equal to 1, or 1 is less than or equal to x, saying the same thing. All right, a couple more multi-step, right, where we have to use the distributive property first. So we'd have 2x. Now this is a common mistake. We have to make sure we multiply both terms. 2 times positive 3 would give me a positive 6 is less than 17. So now that I have the parentheses taken care of, now I can solve, right? So my variable's over here. I want to get rid of the positive 6 first. So here we have 2x That cancels. 17 minus 6 is 11. And, excuse me, divide by 2. Divide by 2. We get x here. We get 6.5, 6.5. We'll just go decimal. That's fine. I got to decide, do I flip the sign? Well, what did I divide by? Positive 2. That stays the same. And it's not 6.5, excuse me. It's 11, which is 5.5. So my solution should be x is less than 5.5. Pause the video here and see if you can do number 2 and 3, right? Start out by simplifying, and let's do that together. So we'll have negative 8x, that would be negative 4, greater than 20. Okay, over here we have 15 greater than or equal to, clean that up, greater than or equal to, here we have negative 3x. Gotta be careful on this one. We have negative 3 times negative 2, which is positive 6. Okay, take a minute and see if you can solve from there. Pause the video and check back. All right, so let's see how you did. Hopefully you were able to solve that down and get x and negative 3. And actually we get that in both cases, right? And here, if we look, we divided by a negative 8 to solve. So I know that I divided by a negative. That flips my sign in the end. Here we divided by a negative 3 when we solved it. So I have to flip this sign here, right? And this is okay. But if we want to write variable first, we flip everything, right? So x comes on this side, opening goes to that, and then negative 3, right? Either or is a correct way to write that. All right, and then our last kind is when we have variables on both sides. All right, so again with this, right, as long as we're doing the same thing to both sides, it's okay. It doesn't matter the order in which we do it. And this is just a personal preference. I know working with some of you that came down to my room, you like bringing the numbers over first, and that's fine. Some of you like bringing it to the right side. Some of you like bringing it to the left. It doesn't matter. So for example, if I look at this, I have a variable term and a number term on the left, variable and number term on the right. So it doesn't matter. My personal preference is I like to get the variable on the left because in the end, I like to have variable, my inequality, and then a number. But that's just personal preference. You can do as you wish. So I'm going to solve this by starting to get the variables together. Since that's minus 1n, I'm going to add 1n to both sides. So here, 2 and 1 would give me 3n, and I still have that positive 5. Over here, I have the 11, ends cancel out, right? Meaning I just moved it from one side to the other. Now this just becomes a two-step equation that we just looked at solving. So here's my variable. I'm going to go minus 5 from both sides. That leaves me with 3n here and 6 here. Divide both sides by 3, and we get n and 2, right? Notice I divided by a positive 3, so my sign is going to stay the same in the end. Now, for number 2, I'm just going to just to show you that it doesn't matter which way you do it, and this is just a preference for me to get my variable over here. For example, some of you might say, all right, well, I'm going to get rid of this number first. Okay, so we go minus 1, minus 1. And that's fine. So over here I have a y. That cancels. Over here I have 4y plus 3. So now we want to move the y to the other side. So we can go minus 4y. So remember that's an understood 1, so that'd be negative 3y cancels and 3. So I'm going to solve this by dividing both sides by negative 3. And we get y and negative 1. Notice I divided by a negative. My sign would then have to flip, right? So y is less than or equal to negative 1. Okay. I am going to back this up and erase it. That is the correct way to do it, right? And notice I did numbers first there, and that's fine. Let me just show you a common mistake that I see when solving. Okay, whether it's an inequality or whether it's an equation, right? An equal sign or an inequality. Here's one of the common mistakes. And really what it does is it affects the sign being positive or negative, right? And that could cause you obviously to get the problem marked incorrect. And I'm going to do this in a different color so we know this is not correct. Right? I see this often. So we'll go -1 from both sides, and we have y here cancels 4y plus 3. Okay, so we're good there. And then I'll see this minus y, and then I'll see over here 3y plus 3. Okay, and then I'll see divide by 3, and we get y and 1, and then you'll see, okay, I divided by the 3. I'm just going to go like that. But if you notice, what we did is we did everything on one side, so it's not correct anymore because we've neglected this side. This is really 0 over here. So you brought both the numbers and the variables to the same side. Okay, remember you have to get variables and numbers on separate sides. So let me back it up. Again, we'll go green because this is another way to do it correctly. Some of you might do this. You might say, okay, well, I'm going to go minus y minus y. All right, so that cancels. We have a 1. Here we have a 3y plus 4. So now if you look, my variable's on this side, which means I want to get all the numbers to the other side. So I can go -4, -4. Notice I did that on both sides. So that would give me -3, cancels, and I have 3y. So I divide both sides by 3, and we get -1. I divided by positive, so it stays the same. And this is going to be y. Okay, and if I wanted to write it like I originally solved, that's why I like to have the variable move to the left side, so I don't have to change it in the end, but that is just a personal preference. All right, pause the video here and see if you can solve number 3. All right, so let's see how you did, right? Again, my personal preference is to get the variables, right? See, I have 1 on each side. I always take the one that's on this side and move it over. Again, just personal preference. You can do whatever you're comfortable with. Should have gotten -1x plus 3 then. Subtract 3 from both sides. We get -1x is -7. So when I divide by -1, right, -7 divided by -1 is +7, right? So we've isolated the variable here. Solution on the other side is 7. Now I got to decide what to do with my sign. Notice I divided by a -1, so when I bring the sign down, it has to flip. So x is greater than 7 should be my solution for that one. All right, I'd like you to try the following problem starting on page 357. Okay, here's the set that we just looked at, right? It starts with two-step equations, introduces some parentheses, and then has a few with variables on both sides. Notice just solving it, just like we did up here. You don't have to do the graphing part of that, even though the directions say so. And then 50 to 58 even, some review problems for you to work on. So try those on a separate sheet of paper, and then you can use the answer key to check. All right. I hope you all have a great day, and we will talk to you soon.